Alright, so here's another set of equations here. We're going to solve this system if possible. X plus y is equal to 13 and x plus y is equal to 9. Alright, so we have x plus y is equal to 13 and yes, and x plus y is equal to 9. So what we're going to want to do here is solve for x or y in this problem. It doesn't matter. I'm going to go ahead and just solve for y again. Or no, I'm going to solve for x. So x is equal to 13 minus y. So you see I just took this y to the other side. And then I'm going to take this x right here, replace this x with 13 minus y. So we're going to have 13 minus y plus y is equal to 9. Alright, and simplifying, we have a negative y and a plus y, so that's going to cancel out to 0. And so the left hand side will be equal to, whoa, wait a minute there, Bessie. That's not possible. So something fishy's going on here. We get a number 13 is not equal to 9, at least not in the number system we're working with here. Maybe in another number system you could get that to happen, but what's actually going on here? Okay, let me just kind of sketch out the graph here. All right, if we were to graph this, this thing's going to have, what is it going to have? I'll tell you what, I'm just going to solve for y in this problem. We got y is equal to negative x plus 13. There was a section where we did some graphing. This has a slope of negative 1 and it passes through the y-intercept at 13 up here, which means that it's going to pass down here through 13. And so if I could draw a straight line, okay, so, and then this one here is going to be the same way, except it's going to pass through here at 9. So the reason I'm drawing this out is so we can kind of better see what's going on here. Okay. What we got going on here is we got two lines with the same slope, and they're parallel to each other here, but they're not the same. Okay, and they don't intersect, so they're not intersecting anywhere. These lines don't intersect, and therefore, if they don't intersect, then there is no solution. No solution, right? No solution. So I'm going to click the answer here and it says no solution. Okay. So this is one with no solution. The slopes are the same. These are just two parallel lines, but they're distinct lines. They're distinct parallel lines. You know, they could be the same line. The same line means they'd have the same slope and they'd both technically be parallel, I guess, and whatever. But no solution on this, and that is because we got down to this point right here and our variables canceled out. Alright, so if this happens, we got no solution. We're going to look at another case where there's an infinite number of solutions. So actually what I'm going to do now is we're going to kind of go through all the possibilities here of finding a solution to a system of equations, and what we're going to do this is we're just going to look at this graphically. Alright, we're going to look at this graphically. So what are our possibilities? Now I'm not going to draw the XY axis here. I'm just going to draw the lines in the plane. So our possibilities is here. We could have a line and then another line, and of course this is where they intersect. That's the point we've been looking for. We could have two parallel lines. Okay, we could have two parallel lines, so that means no solution, right? So this is no solution. Right, no solution. This means one solution. I'll just write x, y as ordered pair here, right? So this is one solution. Now we got another possibility, and that other possibility is if we had a line, okay, and believe it or not, it's going to make sense, another line that's directly over the top of that line. Okay, so where these two lines intersect? Well, they intersect everywhere, right? I mean, they intersect